Hey everybody! Today we're going to talk about properties of parallelograms. We're going to talk about some facts about parallelograms, and then we're going to use that information in order to solve some problems. So properties of parallelograms. I'm scrolling down just to see what else we got here. Looks like some exercises to practice with. So let's do that. It says, remember, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So this first image shows that opposite sides are congruent and opposite angles are congruent. Okay, so that looks like a couple of the bullet points here. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. Since opposite sides are parallel, consecutive angles are just like same side interior angles, which are supplementary when lines are parallel. And it says that the diagonals bisect each other, which is what the second figure is showing you. Diagonal DB and diagonal AC bisect each other, which means they cut each other in half. It says you can use these attributes to solve problems about parallelograms. And you can see this example here that wants you to find the value of x. Since consecutive angles are supplementary because they are same side interior angles, then you can simply subtract one of them from 180 to get the other one. For instance, this one is 60, so 60 from 180 is 120, and that's how we know that that other angle is 120. This one says find the value of x. Opposite sides are congruent, so you can set these equations equal to each other. X plus 7 equals 15, and then simply subtract 7 from both sides. There's something I can type in. Okay, and I could have done that up here too. Sorry, I'll go ahead and show the work here. Subtracting 60 from both sides. And that's how they got 120. So down here we are subtracting 7 from both sides, and that is how they got 8. All right, so this one wants you to find the value of x and y, and rolling back up here to the top, because this is showing diagonals. Diagonals bisect each other. They cut each other in half. So I can see that I see the pieces of the diagonals here. This is because the diagonals bisect each other. That means that y equals 3x, and that means that 4x equals y plus 2. So if I start by taking this 4x equals y plus 3, and solving for y, then I could set those y equations equal to each other. So that's effectively what they've done here, except they just took the value of y, which was 3x, and substituted it in for this other y, and now you have an equation that only has x's in it, and we can work with this. So I'm going to draw a little bit here to try to help make this a little more sense. Some of you may be wondering where they got this information. Well, since the diagonals bisect each other, that means that this segment is equal to this segment, which is y, 3x equals y right there. And the two segments of the other diagonal are also congruent, which is y, 4x equals y plus 3. So they took this equation, 4x equals y plus 3, and this equation, y equals 3x, and they simply substituted in the 3x, since it equals y, they substituted in for y. And that's how they got 4x equals 3x plus 3. They then subtracted 3x from both sides. Subtract 3x from both sides. And that cancels out, and you end up with x equals 3. So now that you have that x equals 3, then you're going to substitute this back in for x. So instead of saying y equals 3x, you're going to say y equals 3 times 3, so y equals 9. So we come out with y equals 9 and x equals 3. We have our two solutions there. All right. So here we have some exercises to work based on parallelograms. This first one is showing consecutive angles that we know are supplementary. So since consecutive angles are supplementary, we know that 130 degrees plus that x equals 180 plus x equals 180. So all we need to do then is subtract 130 from both sides, and we'll get our value of x. And yes, I understand that many of you can just do this by looking. Okay, so 180 minus 130 is in fact 50. So I really could have just looked at this figure and said, wait a minute, 130 from 180 is 50, so I know that this other angle here is 50, which is true. All right, here, opposite sides are congruent, so I know that these equal each other. So I know that 5x plus 2 equals 6x. So I simply need to solve for x by subtracting 5x from both sides. I'm going to subtract 5x from both sides. Minus 5x here, minus 5x here. Okay, so these cancel out. Bring down my 2. And on the right side, 6x minus 5x is just x. So now I have the value of x. I'm going to go ahead and switch out colors here. I'm going to stick with the Christmas theme here. A holiday theme. Doesn't have to be Christmas. All right. So on number 3, opposite angles are congruent. Since opposite angles are congruent, then I know that x equals 35. X equals 35. All right. I'm going to go back and put some notes in here in a minute on how we know these things are true. So on 4, we know that opposite sides are congruent, so I can simply set 3x minus 2 equal to 19. And then solve for x, starting off by adding 2 to both sides. I'm going to add 2 to both sides. I now have that 3x equals 21. And that is something that we can divide by 3. So we're going to divide both sides by 3 now. And we can see that x equals 7. Okay, so we've worked 4 of these. I want to go back and add some notes here before we get too much further. So I'm going to switch to purple and type in some notes here. All right, so this first problem we were able to work because we know that consecutive angles are supplementary. Okay, and the second one, we know that opposite sides are congruent. Opposite sides congruent. That's how we solved that one. That's also how we solved number 4. Go ahead and put that note down here too. Opposite sides congruent. All right, number 3, opposite angles are congruent, so we just set those equal to each other and knew that answer instantly. Opposite angles are congruent. Okay, so let's go ahead and look through the rest of these, and while we have the purple up, we'll make notes on how we're going to solve each one of these. So on 5, the diagonals bisect each other is the concept we're going to look at here. Diagonals bisect each other. Okay. Also, the situation we're looking at for number 6, diagonals bisect each other. Okay. On 7, we have 2 pairs of opposite sides here. We know opposite sides are congruent. Opposite sides are congruent. And opposite angles congruent is the concept we're working with on number 8. Opposite angles congruent. Okay. 9, we are showing consecutive angles that are supplementary. Consecutive angles. Supplementary. Okay. 10, we have another pair of opposite sides that are congruent. Opposite sides congruent. On 11, we have opposite angles congruent. And on 12, we have diagonals bisecting each other. Diagonals bisecting each other. Okay, I think that's the last figure we have here. Yeah, and then there's a couple of writing things and then a reading thing. All right, so let's go back and switch to our red and work another problem. Going back to red. Okay, so since the diagonals bisect each other, we are going to start this. I'm actually going to type on this one. We know that 2x equals y, and we know that 3x equals y plus 4. Okay. You can see that those pieces are congruent to each other. Okay, so I'm going to put some markings on here to indicate that. Diagonals bisect each other, which means this segment is congruent to this segment, which is why 2x equals y. And we know that this segment is congruent to this segment because that diagonal is also bisected. And that's how we know that 3x equals y plus 4. All right, so like they did in the previous problem, if we know that y equals 2x, then I'm going to take this 2x, I'm going to substitute it in for this y. And then I will have an equation that has just x's in it. Okay, so when I substitute that in, now I have 3x equals 2x plus 4. And I can simply solve this one for x by subtracting 2x from both sides. Okay. I'm going to subtract 2x from that side. I'm going to subtract 2x from that side. When I do that, on the left side, 3x minus 2x is just x. And on the right side, 2x minus 2x cancels out, and I have that x equals 4. Once I know that x equals 4, then I can take that value and I can substitute it back in to this first equation. And instead of saying y equals 2x, I can say y equals 2 times 4. let's do that. So I can say y equals 2 times 4. So I know now that y equals 8. Okay. So I have my two answers on 5. I know that y equals 8, and I know that x equals 4. Okay. All right, diagonals bisecting each other, same exact situation over here on number 6. So again, I'm going to start by typing out my equations. I know that y equals x plus 3, and I know that y plus 2 equals 3x minus 1. Okay, so I'm going to show that with some markings here. I have these two segments equal to each other, and then I have the two pieces of this diagonal equal to each other because they bisect each other. So y equals x plus 3, and y plus 2 equals 3x minus 1. So I'm going to take the fact that y equals x plus 3, I'm going to put that in here for that y. Okay? So then I will have an equation that just has x's in it. So now I have, instead of putting that first y in there, I'll put x plus 3, and then bring down the plus 2, equals 3x minus 1. Then I'm simplifying. X plus 3 plus 2 is the same thing as saying x plus 5 equals 3x minus 1. And then solving, I'm going to subtract x from both sides, which is going to give me on the right side, on the left side, x minus x just goes away, cancels out, and then I'm left with 5. And on the right side, 3x minus x is 2x, and then I have a minus 1 there. Okay, so my next step then, and I'm going to have to carry this over in a minute. So my next step here then is to add 1 to both sides. Oops. Add 1. I'm adding 1 over here also. Okay, so those are going to cancel out. Let me draw an arrow and move this up here. These are going to cancel out. Okay. Then I have 2x equals 6, and I'm going to continue this up here. Okay. 5 plus 1 is 6 equals 2x. So my last step then is to divide both sides by 2. So I'm going to divide both sides by 2. 6 divided by 2 is 3. 2 divided by 2 is 1, or 1x. So I know that x equals 3 now. So now I'm going to substitute that in to that original equation that we had up there for y. So we had that y equals x plus 3. But now that we know that x is 3, then we can say y equals 3 plus 3. Just substitute that value in. And now we know then that y equals 6. So we have our values then for x and y, and we are finished with number 6. Answers. I know that x equals 3. And I know that y equals 6. Okay. Saving. All right. 7. Opposite sides congruent. So we're simply going to set these things equal to each other. I'm going to switch over to green real quick. Okay. So I know that opposite sides are congruent. Let me put some markings on here to indicate that. That means that this segment equals this segment. And then these opposite sides, this one equals this one. So I'm going to take that information and I'm going to put that in equation forms. So I know that 3x minus 2 equals 2x plus 6. I'm going to solve that right quick. Solve that by subtracting 2x from both sides. So on the left side now, 3x minus 2x just gives me x, and then I have my minus 2 right there. And then on the right side, 2x minus 2x cancels out, and I'm left with 6 over there. So my last step here is going to be to add 2 to both sides. On the left side, I have x, and then minus 2 plus 2 cancels out. And on the right side, I have 6 plus 2, which is 8, of course. Okay? All right. So when we set the other pair of equations equal to each other, so the other pair of equations equal to each other, that would say 2x minus 4 equals x plus 4. Okay, so start by subtracting x from both sides. I'll show you guys what happens here. Okay, 2x minus x is just x on the left side, and then I'm bringing down my minus 4. And on the right side, I have x minus x, which cancels out, and 4 right there. So my last step here would be to add 4 to both sides. So on the left side, I have x minus 4 plus 4 cancels out. On the right side, 4 plus 4 is, of course, 8. Notice that x equals 8 here and x equals 8 here. X is going to be the same value in any single problem. So you didn't have to do the second set of these. Once you know what x equals, go ahead and circle your answer and count your blessings and move on. Okay. All right, so we have opposite angles congruent here. And this is the same situation. You have x's in both places. So I have the two situations here. I have, well, opposite angles congruent. So I know that x plus 35 is going to equal 2x minus 5. I'll put some curves on this thing. Okay, so I know that x plus 35 equals 2x minus 5. And then I know that these other angles are going to be congruent to each other. So I know that this angle, 3x minus 15, is going to equal to this angle, 2x plus 25. I put different markings on each of the pairs to show how that's going to work out. Okay, to show you're matching up the same symbols. Okay, so I know that x plus 35 equals 2x minus 5. So I'm subtracting x from both sides. Okay, subtract x. On the left side, I've just got 35 because x minus x canceled out. On the right side, 2x minus x is x, and then I have my minus 5. So my last step here then would be to add 5 to both sides. So on the left side, 35 plus 5 is 40. And on the right side, I've just got x because negative 5 and positive 5 cancel out. Notice that if you set 3x minus 15 equal to 2x plus 25, when I subtract 2x from both sides and add 15 to both sides again, I'm going to get that x equals 40. So I don't need to spin my wheels on that one because I already have the value of x solved for. So I'm going to count my blessings, circle it, and move on. I think we're back on red, right? Red, yes. Okay, we have consecutive angles supplementary here, which means that these two angles add up to 180. So I'm going to indicate that 110 plus 3x plus 7. 110 plus 3x plus 7 equals 180. Okay, so I'm going to group my like terms here. I only have one x term on the left, so 3x, and then 110 plus 7 is 117. I have that equal to 180. So my next step then would be to group my like terms across the equal sign. So I'm subtracting 117 from both sides. And on the left side I have 3x. 117 minus 117 cancels out. And 180 minus 117 is 63. Okay, my last step then is to divide both sides by 3. And when I divide both sides by 3, I get that x equals 21. All right, that's it on that one. Just one little equation and problem on that one. Okay. So we have opposite sides congruent then on number 10. So I can go ahead and put some markings on those. I know that that's congruent. You know, we actually know that these sides are congruent also, but there's nothing on them, so I'm not really doing anything with those. Since opposite sides are congruent, I can set 10x equal to 5x plus 10. So my first step here is going to be to subtract 5x from both sides. I am grouping my like terms across the equal sign. So on the left side, 10x minus 5x is 5x. And on the right side, 5x minus 5x cancels out and I'm left with 10. Dividing both sides by 5 then is my last step, and I get that x equals 2. We're going to be happy about that one and switch to green for our last two work amounts. Okay. Green. All right, so we have opposite angles congruent here on number 11. So I'm going to put these big wide angle curves on them. Okay, and I know that x plus 60 equals 3x. So solving this for x, my first step then is to subtract x from both sides. And on the left, x minus x goes away or cancels out. I'm left with 60. And on the right side, I have 3x minus x, which is 2x. My last step then will be to divide both sides by 2. 60 divided by 2, of course, is 30. Equals x. And that one's done. See, those are pretty quick. Not too bad. As long as you know your concepts. Okay. And this last one here, the diagonals bisect each other. Since the diagonals bisect each other, that means that I know that these pieces are equal to each other. That piece would equal that piece, which would be helpful if we had anything on them. But what we do have something on is the two pieces of this diagonal. It too is bisected, so those pieces equal each other, which means that 4x minus 1 equals 3x plus 4. So my first step here then would be to subtract 3x from both sides. On the left side, 4x minus 3x is x. I'm bringing down my minus 1. And on the right side, 3x minus 3x cancels out, and I'm left with 4. My last step then would be to add 1 to both sides. So on the left side, I've got x, and then minus 1 plus 1 cancels out. On the right side, 4 plus 1 is 5. So I have my last value for x right there. Okay, let's look at this writing. Write a statement about the consecutive angles of a parallelogram. All right, let's put this in purple. You can actually look up at the notes that we typed in previously. Consecutive angles are supplementary. So let's write an actual statement, a full statement for that. Consecutive angles in a parallelogram are always supplementary. Okay, and 14, write a statement about the opposite angles of a parallelogram. Well, we can see here that opposite angles are congruent, so we can make that statement. Opposite angles in a parallelogram are congruent. Okay. Reasoning, one angle of a parallelogram is 47. What are the measures of the other three angles in the parallelogram? I think it would be helpful to have an image here. So we are talking about angles. So if I'm looking at a parallelogram here, and I know it is a parallelogram if opposite sides are parallel. So we want to indicate that opposite sides are parallel by putting our parallel arrows on them. Then we know what we've drawn here is in fact a parallelogram. Okay? We also know that opposite angles are congruent and that consecutive angles are supplementary. So let's use that information. This tells us that one angle is 47. So I'm going to put that in this acute angle down here, 47 degrees. If opposite angles are congruent, then this other angle is 47 degrees also. To find the obtuse angles, I'm going to use the concept that consecutive angles are supplementary. So I'm going to simply subtract 47 from 180. 47 or 180 minus 47 is 133. Check me. 70. Yep. Okay. So that means that this angle is 133. And since opposite angles are congruent, that means this angle down here is also 133. Oops. Let me back that up just a smidge. Okay. All right. So we're given one angle, and we're able to find the other three just by what we know about parallelograms and their angles. I hope this has been super helpful. I'm going to go ahead and stop this one and go ahead and roll the 6.3 lesson and try to get that recorded tonight also. All right. Thank y'all so much.